Hello everyone, welcome back to Let's Unbound. In today's video, we are tackling an exam style non-calculated problem from Unit 1. So I have picked a polynomial based question to walk you through, and I will show you not just how to solve it, but also how to present your work clearly so you can earn full credit. So this is a best practice for the AP Precalculus V response section, and it's a solid review to sharpen your non-calculator skills. So grab your pen and paper and let's dive in. Let's go. Let's see the question. So, a new book is released. Let D of D be the number of daily downloads in thousands. After T days, where T is greater than or equal to 0, the observations below are recorded. So, when T is 0, D of D is 100 thousands. T is 10, it's 150,000 downloads. In such a way, they have given this. And T is 60, it's 100, which is 90,000 drop from the peak. Now we have many questions to analyze, interpret, to find the report findings. So this is the thing. So first one, crisply I will explain. So function model we need to construct and justifying the modeling assumptions. Then second problem, I should analyze the increasing and decreasing behavior on the functions domain. And we need to find maximum number of daily downloads and the day on which it occurs. Then we need to compute average rate of change for this time interval, interpreting as our result, and this measure is reliable or not. We need to explain or justify your answer. Then estimating instantaneous rate of change at 3 different instances. What do you observe and explain? And predict the number of daily downloads after 100 days. For approximately how many days is this model reasonable? So all this. Now, the question doesn't end here. Now, there is a change in this ebook release and daily downloads. A marketing campaign changes the download trend of the ebook. The marketing campaign delayed the peak by 5 days and increased the peak download by 10%. So the model will change. Write a new model and then we again analyze the increasing, decreasing behavior and predict the number of downloads. And we will check whether the prediction is realistic. And we will also do how many days the new model is reasonable. Okay, so that is all. Now, let's get into the problem solving. First, we have to create a model, function model, and we need to tell the modeling assumptions. Okay, first thing we can see here is I have just listed that they give the record, right? I have listed it in table. Usually, we will go up with finite differences. But if you go finite differences, you won't get linear, quadratic, cubic, nothing. But don't always rely on finite differences whenever you see the table. See the trend. And also I will tell you why this table will not be working when you try mince. The t values have to be equally spaced. Okay, there is a 10 units gap, 10 units gap, 20 units gap, 10 and 10. That's how. If it's equally spaced, we can do that. But this is not. So we are not doing finite differences. But still, let's try to validate a model for this. You see 100. When it's 0, 100, then at 10, it's 150. At 20, it's just I'm plotting 180. At 40, it's again 180, then again 150 and 100. This shows a symmetric, like a symmetric nature, right? If you just graph the trend, you will get a symmetrical plot and it's raising, then it's coming down. So what do you think? Which model will best suit here? I can hear your answers. It's quadratic, right? So yes, we are going to do this with quadratic. And because of the, like when you model, you can just say symmetricity of the daily downloads versus the number of days, correct? The data are symmetric. And whenever you say this, the data is symmetric about which point? Like when we say parabola, it is symmetric about like vertex, right? If you cut it along with the vertex, then it will be symmetrical. So that vertex finding is important. Symmetric, okay, fine. But where it is symmetric about where it is symmetric about. Okay, so this is symmetric about which t point or which vertex. So let's find it. So we observe the data are symmetric about, how will you find it? The data are equally spaced. So like where it crosses x-axis or something. Or you can just take the symmetrical points and find the midpoint, you will get the vertex. Take two symmetrical points, find the midpoint. Any two symmetrical points. You can pick 0, 60. They are symmetrical, right? Because 100, 100, they got reflected. 10 and 50. That also you can choose. But everything will give you the same. and find the midpoint. Okay, 0 and 60, add and divide by 2, it will give you 30. If I take 10, 50, add and divide by 2, it will still give you 30. So 30 is the t coordinate, like the value of t where you have the parabola vertex. Okay, so now what about that? So after 30 days, there is a peak download. Okay, but how many downloads on that day? Yes, we have a clue in the question. When they give, let me go back and show it to you. T equal to 60, it was 100, which is 90,000 drop from the peak. So what would be at 30? It should be 190. Then only 90,000 can give you 60, 100. Correct? So from this, I can analyze it's 190. Okay, so the respective. So it's symmetric about t is equal to 30 and respective d of t is 190. So I got the vertex. If you got the vertex, then vertex form of quadratic, we can model it. So d of t is a times t minus 30 the whole square plus 190. We need to find a, and you can just use any point. I will pick this easier point. When t is 0, d of t is 100. So 100 equal a times 0 minus 30 the whole square plus 190. And subtract 190 on both sides. You will get negative 90 is a times, this will cancel, 30 square is 900, so a times 900, and your a would be minus 90 over 900. And this will result in 1 by 10. That's it, I got my a and model is complete. So the complete model is d of t equal negative 1 over 10 t minus 30 the whole square plus 190. So this is the model. Now in next page, let's do the modeling assumptions. Okay, so what makes you to think it will be quadratic model? Symmetrical nature, right? So we can say that first. So we assume that, so instead telling that d of t is symmetric about t like that, go with the way of telling in the realistic way. Realistic way means d of t means it's math language, right? So we can say the daily downloads instead there, correct? So modeling assumptions. So first is about the daily downloads. So the daily downloads raised to a single. So we observed that, right? 100, 150 like that. We first did this, correct? So that is our assumption. So the daily downloads raise to a single peak only. We don't have multiple peaks. So single peak and then it drops. Or you can say they fall. It falls. And this rise fall, so that tells you, okay, parabola will be the best fit. So simple parabola will fit this. Okay, so next part is, this is our assumption. Okay, why didn't you choose other polynomials? So think in that way. Why I rely with quadratic or this one? Any other thing? So yes, the symmetrical nature, right? The daily downloads are symmetrical in nature. And it's symmetric about t is equal to 30, or you can give the vertex 30, 190. Right, so for 190, they give you the clue. So it's not an assumption, we just got it. So these are the assumptions we made to pick the quadratic model. And yes, this justifies the quadratic model is the best here. Okay, so yes, and that's it. Yeah, you can mention one thing here. So whenever you write the model, you can write t greater than or equal to 0. It is given in the problem itself, but yeah, that is the one. Okay, no need to find the domain here. Just say what is the suitable t values. That is enough. Okay, moving to second part. Determine where d of t is increasing and where it is decreasing on its domain. Okay, so first we need to find domain, then we will check the increasing, decreasing behavior. Okay, so, and one more thing, you know it's 0 to 30, 90, then, sorry, 190, and then it goes like this. So we know this is increasing, but what about here, ending point where it decreases? You can't write negative till it's infinity, right? So Let's check the reliability and let's work on the domain. So domain t greater than or equal 0 for sure. And download also cannot be negative. It can be 0 download or greater than 0. So let's solve this. Negative 1/10 t minus 30 the whole square plus 190 should be greater than or equal to 0. Solving this will give you a restriction for t. Okay. Right. So subtracting 190 on both sides. Okay. So that will give you negative 1/10 t minus 30 the whole square is greater than or equal to negative 190. And multiply by negative 10, that will give you t minus 30 the whole square is greater than or equal, less than or equal, right? Because when you multiply by negative number, 1900, and let's continue. T minus 30 is less than or equal to square root of 1900. I didn't use negative here. Usually it will be plus or minus. Why I didn't use negative? We are talking about t, no negativity possible, right? So t minus 30 is less than or equal. You can write it as 10 root 19 and add 30 on both sides. So t less than or equal to 10 root 19 plus 30. If you want exact, you can go with that. But for interpretation, we need the approximate at least, the days, right? So in that case, you can just use the values. So 10 root 19 plus 30. Okay, root 19, if it's non-calculated, they will provide you what is root 19. And yes, or you can just leave as it is. So what happened if you choose beyond this, like 10 root 19 plus 30, if you do 31 plus 10 root 19 or something. So I will tell you, this is approximately 73.589. Right? So that's our domain. It should be greater than or equal 0 and approximately 73.5 days or 6 days. So this is your domain of t can be this. Okay, so we find the domain. Now increasing, decreasing is so easy. So 0 to 0, 100. Okay, actually we are looking at 0, then 30 at peak. Then it comes to 73.5. It will again attain 0. Below that, it's not possible. So this is increasing and then it's decreasing. So we can write it's increasing on 0 to 30 and decreasing on 30 to 73.5 approximately. Right, so that's all. And here we go for the next part. Find the maximum number of daily downloads and the day which occurs. Actually, while modeling itself, we got it, right? So maximum number of daily downloads, the peak, actually they mean. So the peak is 30, 190. That itself has the answer. So maximum number of daily downloads is, don't write 190, and the unit is 190 thousands. And which day? At t is equal to 30. That's it. Now, compute the average rate of change, d of t, wait. From t equal to 20 to 40, interpret your result. Is the average rate of change a reliable measure here? Explain why or why. Okay, so how will you how will you do the average rate of change? Is 20 to 40 means d of 40 minus d of 20 divided by 40 minus 20. Yeah, we have the table. It's 180 minus 180 by 20. Anyways, 0 by anything, it's going to 0. So average rate of change is 0. So which means no rate of change. So why this happens? Is the average rate of change a reliable measure here? What do you think? Actually, we can see clearly 20 to 40. There is an increase and decrease. It's cancelled out basically in our computational things. But yeah, there is a rate of change which is rising, decreasing. It's not a 0, like, right? Neither increasing nor decreasing. That's not the case here. So this is not a reliable measure because we can clearly see the nature of the graph being increasing rate of change, decreasing rate of change, right? That we can see it, but computational value gives 0. Why this happens is average rate of change in graphical sense, it's a secant line. A or OC, in graphical way is slope of secant line. And this secant line connecting the 2040, right, is a horizontal line. Horizontal line always have slope 0. Usually their slope is 0. So why this happens? Here, due to symmetrical nature, we got a horizontal line and hence the slope is 0 here. So this is what we observed here. So yes, now coming to the interpretation. So why we got 0? We can clearly see the increase decrease behavior. It got cancelled out. It is misleading in this case. The average is 0 because increase and decrease cancelled out. Exactly, I got 180 and 180. Correct? They got cancelled out. So the average hides the important shape. It removes the it removes the information about when the increase and decrease happen. If we got 0 means so no change, or there is no change till the 23 to 43. No, there was a lot of change happening. But due to this this measure is not reliable here. It's misleading because this average rate of change hides that important shape. It removes the information about when the increase and decrease happen. That's why average rate of change sometimes is not working. We are using the instantaneous rate of change. So simply we can write not reliable. And the thing is, this average rate of change hides the increase and decrease. Yeah, there is a lot of changes over there. Increase and decrease rates between the time interval. It gives just single value, but it is not between t equal to 20 and 40. That's the problem. Right? So that's why it's not reliable over here. And for interpretation, you can use the slope, secant of the slope, that case. Now, fifth problem. Estimate the instantaneous rate of change at t equal to 25, 30, 35 using your model. What do you observe? Yeah, so this is my model. Instantaneous rate of change for I or OC at t equal to 25. How will you do this? We can use the table also. Let's approximate this. So where 25 comes, it comes in between this. Okay, actually we got from our model, we got 3180. We can use it for better approximation. So 25 will come here. And so you can just choose these 2 points, right? So d of 30 minus d of 20 divided by 30 minus 20 and solve for it. So 190 minus 180 by 10. 10 by 10 is 1. And unit is important. We got plus 1. It's 1000 downloads per day. So I'm just writing K downloads. 1000 downloads per day. Okay, this is what I got. Then IROC at 30. Same way, instantaneous rate of at t equal to 30, I will pick 20 and 40. Whichever is available to me, I will do that. So 180 minus 180 is 0 and 20, which is 0 downloads per day. 0,000 or 0 downloads per day. Now, IROC, instantaneous rate at t equal to, we are doing it for 20, 30, okay, 25, 30, 35. So 35 lies between this, correct? So we can do 180 minus 190. Okay, the order is important. Then 30 minus 40. So we got, wait, 40 minus 30, right? 40 minus 30, so negative 10 by 10, we got negative 1000 downloads per day. Okay, it's not a number of downloads, it's rate. So negative, it's okay. So yes, we got all the instantaneous rate of change. So what you observe here, even the rate of change is symmetrical in nature. correct? We find the instantaneous rate of change. So we can see it's +1, then +1 means increasing behavior, rate of change, right? Then it's 0 drops, then it comes down. So it again confirms that quadratic will be the best fit for this real life model. Okay. Even these estimates are symmetric. So I'm doing the observation here. So t equal to 25, 30, 35, we got -1 plus 0, 1 plus 1, 0 and -1. So the estimates are symmetric. That matches the estimates or symmetric. That matches parabola. So this again confirm the parabolic model is good. So what else we can observe here? The shape of the speed of increase, right? It increased 1,000 and before the peak, and it decreased also the same peak. So it is same in magnitude. So speed of increase before peak is same in magnitude. We are just saying magnitude, not about the sign. Magnitude as the speed of the decrease after the peak. This is also we can observe. That's it. So we completed the 5th part. Now 6th part. Predict the number of days, number of daily downloads after 100 days. So after 100 days means t equal to 100. We have d of t in hand, right? So -1/10 t minus 30 whole square. We did this in first step, first problem. Plus 190, just put 100. So d of 100 would be -110, 100 minus 30, right? It's 70 square plus 190. So this will give -100. 70 square is 4,900 plus 190. Cancel this. 190 minus 49, it's around 190 minus 49 will give us, for sure it will give us negative. Oh, 4, oh, it's 1/10. That is a confusion. Okay. So 4,900, this will get cancelled. So we got 49. This is how it should be. Minus 490 plus 190. And we got -300 downloads. It's not possible, right? So we got an absurdity here. And let's see a follow-up question. For approximately how many days this is reasonable? Yes, at 100th day, it's not quite reasonable. So let's find how many days it's reasonable. Your domain is the answer for this. We already got the domain. Here we go. So our domain is like t can be greater than or equal to 0 and approximately 73.5 days. Correct? So that's why it's out of domain. We got some absurdity when we do for 100 days. So the model is reasonable until approximately for 73.5 days. And explain the reasoning, it's quite simple. So the model is reasonable for this, and out of this we have negative downloads, which is an absurdity in nature. So that's why there is a restriction. It goes like your parabola will cross the x-axis and go below. Negative downloads is not applicable in this realistic situation. Right? So after 73.5 days in approx, the graph cross x-axis. Okay. And got negative y values. Here, negative downloads. Negative downloads is not reasonable. So that is why it's until 73.5 days. Right? Now, here. Now, a marketing campaign changes the download trend of the ebook. The marketing campaign delayed the peak by 5 days, increased the peak download by 10%. Write the new model and solve these questions. So let's go for first part. Writing a new model. From that model, they are making changes. So its transformation is best applicable. So d of t is delayed by 5. So d of t minus 5, right? Then plus 10% of whatever we have, correct? In that way we have to do. So they are doing the changes in the peak. Let's do like this. So peak is getting changed. So that 30 comma 190 will change to what? Delayed by 5 days means after 35 days only. It's not 25 or something. Okay, 5 days delay means it takes extra 5 days to reach the peak. And 10% increase means what you will do? 1.1 into the old peak download. That's it. So 35, comma 1.1 into 190 is 11 into 19, which is 1999 to not. Okay. So the vertex alone changes, rest everything will change. So the new d of t would be d of t minus 35 and then this value. So let's directly go. It's negative 1/10 t minus 35 the whole square plus 209. No other things will change here. So that's the part. We make a model out of this and state the constraints with reasons. So constraint means any restrictions we have either for t or d of t. Let's do. We can do it here. Okay. So t should have to be greater than or equal to 0. We are sure. And of course, d of t is also greater than or equal to 0. So negative 1/10 t minus 35 the whole square plus 209 greater than or equal to 0, and we can solve for this. T minus 35 the whole square is greater than or equal to negative 209 and multiply by negative 10. T minus 35 the whole square is greater than or equal to less than or equal to 2090. And t minus 35 the whole square is less than or equal square root of 2090. T is less than or equal to 2090 plus 35. We can keep as it is in exact form. So this is a restriction we have between 0 and this value. Now, on which intervals or d of t increasing and decreasing on its domain? So 0 to 35 is the peak. Then the restriction is that value, square root of 2090 plus 35. So we can say it's increasing and then decreasing, concave downward parabola. So it's increasing on 0 to 35 and it's decreasing on 35 to this value. Right? That's it. So this is how we need to check on it. It's same kind what we did for the original model. Now predict the number of downloads after 60 days. And is this prediction realistic? Why or why not? So for this new model, d of t is negative 1/10 t minus 35 the whole square plus 209 and just plug in 60. Negative 1/10 t minus 35, that is 60 minus 35, it's going to be 25 square plus 205. Sorry, 209. This will be 625 and 625 by 10 is 62.5. Negative 62.5 plus 209. For sure, this will be greater than 0. So in this prediction is realistic. Let's get exactly what number it is. 209 minus 62.5. 209 minus 62.5. 146.5. Yes, this is realistic prediction. Because it's positive, so it's possible to have half a download. Someone will download after they got a good Wi-Fi, right? So half downloaded is fine. And that's it now. So if it's a calculator paper, you can approximate these values, right? So, but here we are just keeping it as same. For approximately how many days it will be, the model will be reasonable. I think the new model. T of t is reasonable for how many days? Up to. So that domain we find the extreme end value, right? That one. So square root of 2090 plus 35. Approximately they are asking. So it should be, we can use calculator and you will get approximately 80.7. Okay, don't round up, try to round down. So the new model will be applicable till 80 days, right? And yeah, that's the wrap for today's video. And yes, You have did amazing on Unit 1 journey. And with this exam style problem review, I hope you will get some clarity on how to solve, how to present your answers in exam. And we will be creating another new playlist, especially for AP Precalculus students, which is on Unit 2. And same way, you will get review plus problem solving sessions, and finally, one exam style problem solving for Unit 2. So stay tuned with Let's Unbound. You can join us by scanning the code given here, or you can click the link given in the description. So do watch the playlist. If you really like the content, you can show us some love by liking it, sharing it with your friends, and also you can subscribe to us. Thank you for joining. Let's meet in new playlist. Until then, keep learning, keep practicing, stay curious.